Just over 2 years ago, the Harvard Stem Cell Institute decided to invest in creating an induced pluripotent stem cell core. The idea behind that was that rather than recreate in each individual investigator's laboratory the means to make induced pluripotent stem cells, it might be a lot smarter and more cost-effective to create a core that the community could use. And it started small in a location here at Mass General Hospital in just one room with two people working to get it up and established. And in just that first year, they were able to adopt new technologies and implement them for the first time in a sort of rigorous and thorough way. They created just over 30 cell lines for investigators both here at Mass General and in the Longwood campus. Seeing how valuable this would be, the steering committee at the HSCI in general and the executive committee decided that further investment in this core was probably a smart idea. So they established new space in Cambridge, which we moved to just over a year ago, which is about 3 times the size, and will allow us to have up to 16 total staff members. Currently we have 8 full-time staff that are working in the core facility, and over the course of the last year we've now served well over 30 different faculty members part of the HSCI to make induced pluripotent stem cell lines, and the number, as it was last reported to me, is around 400 pluripotent stem cell lines. So I would say it's been a massive success. What we see happening over the next few years is an expansion of a lot of the services we offer. The most important sort of barrier for getting involved in this, especially in terms of using the cell lines that we create potentially for therapy, is that the technology that's been used to date actually integrates into the genome of the cells. And as a result, it could cause potential cancers, and it could be something that would be making those cells incompatible for cell transplantation. So we've worked hard to try to adopt new non-integrating technologies. So technologies that would allow you to reprogram a somatic cell back to an induced pluripotent stem cell, but not actually change the genome in any way. And working on the breakthrough technology of Derek Rossi, we've been trying to integrate and utilize his modified RNA reprogramming methodology. And as a result of bringing that into the core, we thought the smartest way to implement that at the large scale that the core needs would be to actually ask Derek to help us co-direct it over the next year. So Derek Rossi generously agreed, and now we share the position of directors of the HSCI Induced Pluripotent Stem Cell Core. The last thing I should mention is that the core is still doing a lot of activity in accelerating certain types of research. So one of the main functions right now is it's partnered with a large cohort that may be well understood in the Boston area, the Framingham Heart Study. This has over 30,000 individuals that have been followed now for well over 40 or 50 years. And from this study, we've learned important things like smoking is bad for you and causes cancer, or that eating fatty foods can give you a heart attack. These types of epidemiological studies have given us tremendous insight into what's good in the environment or bad in the environment for health. And in the last 10 years, they've taken a step into the next generation where they've asked, in these large studies, are there genetic basis for many diseases that we didn't understand might have a genetic basis, such as obesity or mental illness or even cardiovascular disease. So it's from these studies that we've learned that there are certain common mutations that all of us carry around that give us an increased predisposition for, say, a heart attack or to be obese and have diabetes, for instance. What we've decided to do recently is partner with the Framingham Heart Study in a large collaborative project that's now funded by the NIH to create from their most well-studied cohort of individuals approximately 3,000 induced pluripotent stem cell lines, with the hope that these stem cell lines could be used to try to further explore the molecular basis for diseases such as cardiovascular disease, heart attack, diabetes, and mental illness. Just over 2 years ago, when a group of us came together to discuss forming an induced pluripotent stem cell core, I was on the furthest extreme in saying that it was crazy. No one was going to use it, it wasn't going to be useful to the community, and there wasn't going to be much benefit. My reward, of course, was to direct the core, and I've learned over the last 2.5 years that it's been empowering for people's research, not only my own research, but research across the community. We've now begun to distribute lines to the world to use to try to combat problems such as Huntington's disease, Alzheimer's, diabetes. So this is not only a resource for research, but it's actually sort of an investment in the future, not only at Harvard, but at the entire research community in Boston.